Hello Year 12, welcome to our 5th video here for our 9th topic on networks. We are looking at activity tables and forward scanning now. These are moving into a different area to the types of graphs we were mostly looking at before. We are mostly looking here, well I suppose we will be looking at directed network graphs from now on mostly. That means they have arrows on the edges, means the edges can only be traversed in one specified direction. And they may be weighted directed network graphs, which means they also have some sort of numerical value attached to them, which would be labeled on there. We start now, at least in this exercise, labeling our edges and not the vertices, which has been the convention until now. So this time, the edge is the most critical part, right? And the vertex is just sort of a checkpoint, an indication of where that activity starts and finishes. Now, we might be using these to model things like, all of the different things that happen when you build a house, perhaps, or perhaps when you are cooking a meal, right? There are different elements that need to come together. Some of them, right, some things can't be done, some activities can't be done until a different activity has been completed. For example, when I get dressed in the morning, I can't put my shoes on until I have already put my socks on. Okay? But I could, for example, brush my hair before or after. Wouldn't make any difference. Right? But can't put my shoes on until I've put my socks on. What we are looking at in these activity tables, we are looking at what activities have to be done before I can do this one. And that's what I'm going to call a predecessor. So, looking at my activity table first, right, you can see the list of the activities there, A through H. Some of those, or at least one of them, has no predecessors. Right? To complete activity A, I don't have to have done anything else first. But I can't do B or C or E without having done A beforehand. I can't start activity D until I've completed B. And I know that I can't do B until I've completed A. So, my activity table is helpful in some respects. Okay, I can directly see lots of those things. I can see the time required to complete each of those activities. But I think the network graph, the diagram here, okay, can explain some of that a bit more clearly as well. So I can see here is activity A with nothing before it, no predecessors. And once I've completed A, then all of a sudden I could begin C or E or B. Right, so that's what causes things to branch out. What causes things to come back together? Okay, so these are certainly not trees. Right, these do have loops of sorts in them. They come back together. So we can see that E and D, those activities rejoin at a single vertex here, which is not labeled. E and D rejoin, and that is because they are both predecessors for F. I have to have done both of these things before I can do F. The same thing goes with H, that it relies on both F and G being completed first. So H has two predecessors, right? And that means that there are two edges that come together. Now, we may be asked to draw the graph from the activity table. A couple of issues, some practicality issues with this. One, it takes quite a long time. It's fairly hard work, which is a bit of a challenge in an exam. Two, from the marker's point of view, there are so many different ways for a moderately complex graph to appear. It can be very slow to mark them. So we'll have to wait and see how the markers, or how the people who set these HSC exams, we'll have to wait and see a little bit to see what they do with these. But I think much more reasonably, you'll get perhaps a partially completed graph, and you'll have to add something to it. You might have to interpret the graph and say, what is the predecessor of F? And you'll say it's E and D. Or perhaps you will have the graph and you need to fill out the activity table. That's relatively straightforward. Now we're going to do the hard one first. In example 10, I'm going to draw a weighted directed network graph to represent this activity table. A has no predecessors. Right, B and C come from A. Now, keeping an eye on G, E and F will have to come together. In fact, I think I might sort of work backwards from the end. I think I'm going to say, right, let's consider this. Let's call that activity G, and both E and F have to come together for that to happen. I'm going to call this one E and this one F. Rightio. Now, predecessor of E is B. Predecessor of B is A. So is B the predecessor? No. So I can have, oops, I said it was E. Okay. B is the predecessor for E. D is the predecessor for F. Right, so you can see I've sort of worked backwards here. There's G. I could see that there was two predecessors there, so they had to come together. Right, I've done that. And then before E comes B, before F comes D. Now before D comes C, and I guess I can do that there. Before C comes A. Now, I think now it's to be neatest. Oops. What am I going to do here? I think now C comes from A and B comes from A. So I think if we draw A here, oops, no, that's not how it goes. Okay, what's happening there? Not much. Now back to the drawing. Okay. Now A joins to B and to C. So I need to have. I'm going to extend my B back here a little bit further. Okay. Now that's going to be C there. Okay, because both B and C have a common predecessor of A. So we go A, and then I could go B or C. After C comes D. After D comes F. Right? D is the predecessor of F. And I think that's all of it happening there. Okay, we've got A, B, C, D, E, F, and G. That's the hard part of this, I find. Now, we should talk about dummy activities. Dummy activities occur, right, in a situation a little like E and F being both predecessors of G. But what would happen if I had, let's say, an activity H, and the predecessor of H was E but not F? Where would that go? It becomes a problem with these graphs. So what we do is, right, we don't, in that case, bring E and F together. Right, we keep them separate, except for a dotted line, an activity edge, right, a dotted line with an arrow on it, that would go from E to F. Right. That's called a dummy activity. It has no weight, and we do that when there are a pair of predecessors for one activity, but one of those predecessors, but not both of those. So only one of those predecessors is a predecessor for a second activity. Now, we will have an example where that works here. So here we go. Notice that A and B are predecessors for D. A is a predecessor for C, but B isn't. Okay, I've got a pair of predecessors here, and only one of those up here relating to another activity. So this is where we have to use a dummy activity. Let's have a go at doing this. Now I can see that both A and B have no predecessors. A and B. A and B. I should put these little things in. A and B. Now, C. Right, C has a predecessor of A. So C can go here. But D has a predecessor of B. Right, that's good. D, but also of A. So I have a little dummy activity. I'm going to draw it like this. That's what my dummy activity looks like. And that tells me that the predecessor of D is both, follow this along, A and B. Right, and now I can say that E comes here. Right, so a dummy activity because there were two predecessors for this activity, but only one of those predecessors also relates to this activity. Now, we are going to move along to the idea of a critical path, earliest starting time, and forward scanning. Oh, actually, I'll need to delete a couple of things here. Actually, no, this video is getting out of control. I'll make it a part A and a part B. Okay, let's just sum up what we've got going on here. We looked at activity tables, right, and this idea of a predecessor. So these are directed network graphs and sometimes weighted directed network graphs. Certainly for the next part they will be. That we can have no predecessors, we can have one predecessor, we can have more than one predecessor. If an activity has more than one predecessor, then those two predecessors are usually drawn coming together. However, we need to use a dummy activity where I have two predecessors for one activity, but only one of those predecessors is also a predecessor for a different activity. Okay, so you've got to sort of scan through that predecessor list and go, right, I've got a pair there and one of those belongs somewhere else, so I need a dummy activity. Fairly tricky, I know. Keep practicing. I'll be there in class. See you then.